My name is Barbara Dubach, and in session 5 of the Resource Revolution Trainer, we will focus on organizational issues. Following the previous session in which we described the building blocks for becoming a Resource Revolution enterprise, in session 5 we now focus on organizational issues. This takes us to the enterprise and ecosystem stages of the 5-stage Zeronautics transformation process described by John Elkington. It involves moving from the product and service focus to enterprise, its processes, and also its overall performance. This session uses as reference a selection from the organizing principles identified by Heck and Rogers in the book Resource Revolution. The enterprise stage on one side involves taking innovation to the enterprise level or setting up a new enterprise. This includes the challenges of financing, growing, and operating new business ventures. Success factors include tackling efficiencies early on, but moving on to greater scale opportunities as soon as possible. An example is the Path to Zero program of PepsiCo, aiming, among others, at becoming fossil fuel-free by 2023, eliminating sending waste to landfill, and making its product packaging renewable, recyclable, or biodegradable. The ecosystem stage is critical in taking things to scale. It includes the use of the business ecosystems or clusters, including geographical or sectoral clusters, horizontal or also vertical clusters. So vertical clusters in the sense of the whole value chain, looking at the whole value chain. Now, the principles that we will be focusing on are, first of all, standard operating systems, network organization, also resource productivity metrics, productivity talent, and participatory innovation, which are all important while organizing the Resource Revolution enterprise. These principles address management procedures, the forms of organizations, metrics, human resource management, which will change, as well as new ways of engaging external players such as your customers. Let's start with standard operating systems. Standard operating systems help a company to avoid reinventing the wheel and ensure that managers throughout the organization depart from the same standard of already established know-how. The results thereof is improved safety, reliability, stewardship, lower costs, high quality, faster employee development, and more consistent results. Importantly, effective use of standard operating systems in the context of the Resource Revolution requires also the ability to form alliances and also partner via extended value chains. Best practices are, for example, Toyota, Alcoa, and Danaher, who have used standard operating systems to radically improve their operating margins and also the return on capital employed. Standard operating systems are not only about standardization, they also create opportunities for innovation. One example is Apple, who required thousands of independent app developers to use a common standard in coding. Hence, important innovation opportunities exist in the smart application of ICTs across industries. For example, the Kaggle online platform for predictive modeling and analytics can be used by natural resource companies to find competitive statistical analysis, for example, where to drill or mine. The second principle, becoming a network organization, implies new approaches to vertical integration that combines centralized or decentralized management through use of advances of information communication technologies. Heck and Rogers argue that the need to tailor products is even greater in resource-intensive industries, since different local geologies, infrastructures, and environmental risk factors require local solutions. Being a network organization implies the ability to use ICT and facilitate information exchange in the value chain. For example, in the chemicals and white goods industries, it may involve monitoring the performance and maintenance of inventories. For example, gas cylinders monitored from offside by Air Liquide, and equipment, for example, the maintenance of washing equipment by Bosch. Another very good example of a network organization is the Spanish clothing retailer Zara, whose founder, Amancio Ortega, was convinced that waste could be greatly reduced through what he called instant fashion. A first important decision he took was in favor of vertical integration, which is often necessary for resource breakthroughs. The next important decision was to use ICT and have ongoing bottom-up feedback from customers via store managers. Based on this information, Zara is able to adopt clothing throughout the season based on customer and consumer preferences in the different countries. The fast fashion model made popular by Zara is hard for many corporations to keep up with, as Zara sources most of its apparel in Spain and therefore can design and produce new designs quickly. The question now that you can ask yourself is how to measure resource productivity and what kind of metrics exist to do so. Good information sources are, for example, public registers, for example, for a fair distribution of access to water, national accounting systems used by governments to make the link to the national economy and societal well-being, footprint assessments highlighting resource issues in production and consumption, but also life cycle assessments with associated standards and hotspot studies, and stewardship initiatives that provide information to improve quantification, measurement, and reporting. Other sources of information for reporting, especially at enterprise level, are, for example, the Global Reporting Initiative's guidelines and guidance. And if companies are interested in assessing environmental impacts and dependencies associated with products, a range of new tools exists. They include environmental life cycle assessments, environmental profit and loss statements. For example, Puma was the first company to produce an environmental profit and loss statement. Then there are environmental product declarations, input-output modeling, and also natural capital valuation, who starts to measure and monetize natural capital. Environmental profit and loss statements, integrated profit and loss statements, and natural capital valuation help to integrate natural resource use with business accounting and reporting systems, and also internal decision making. This is also of special interest to the integrated reporting framework of the International Integrated Reporting Council, which seeks to bridge the gap between annual financial reporting on one side and annual sustainability reporting. The International Integrated Reporting Council standard requires reporting on the use of 6 capitals, one of them natural capital. The integrated value creation process of the IIRC, which you see on slide 10, shows a combination of input-output framing, value chain mapping, and business model definition. Measuring and taking stock of how your business uses different types of resources is essential in becoming the resource revolution enterprise. The fourth principle is productivity talent. Companies seeking to take on the resource revolution will need to map the likely new skills needed and consider whether to obtain these from schools, other industries, or new business partners. Considering the smart usage of ICT across industries, software talent is likely to be the key requirement for all industries. Increasingly, software plays a key part in the value addition that a hardware product offers. For example, electronics content in cars already provide up to 50% of their value. Finding the right talent may increasingly take global corporations to emerging markets, where the familiarity with scarce resources and ability to establish advanced systems from scratch presents leapfrogging opportunities. In order to find a new pool of talent in areas such as IT engineering, statistics, chemistry, mechanical engineering, and so forth, companies may need to turn to the BRIC countries, which are Brazil, Russia, India, China, and South Africa. An example of a company using talent from emerging markets is General Electric. A low-cost sonogram machine, as well as ultrasound machines, maternal and infant care equipment, are developed and produced in their manufacturing facilities in Bangalore, India, and are now being marketed worldwide. These products are up to 40% cheaper and expected to address up to 15% of the global healthcare equipment market. The case of GE working with innovators in India illustrates what Tuck Business School consultants have called reverse innovation. It's based on homegrown solutions versus top-down globalization, in which GE is disrupting itself. Regarding the new skills required, the International Labour Organization has predicted that skills and training adjustments will occur principally among resource-intensive and carbon-intensive sectors. This is due to the fact that workers in resource-intensive sectors tend to have lower skills levels on average, and they will require the most training. As mentioned in one of the previous models, one of the key factors in reaching decoupling is the ability to innovate at economic, industry, and also company level. Innovative capacity is influenced by the extent of knowledge available, the speed with which it is replaced by new knowledge, the networking of actors who can learn from each other, the availability of finance, and also the right incentives. These are again influenced by institutional factors such as culture, norms, and also leadership. Startups such as Elens and Odesk help companies to find the right talents and match freelance and employers looking for part-time or project-based services. These helps also employers to leverage external networks via the internet. Both companies have now merged to the company Upwork, which you see on slide 13. There are some key insights on participatory innovation, as highlighted also by the International Resources Panel. They are the following. Innovations are different from inventions. While the latter results from a new idea for a new product or process, the former is the synthesis of the idea with the necessary set of financial and institutional arrangements to implement it on a broader scale. Innovation are not random events, but the result of specific incentives and also investments. Innovations do not arise from single individuals or firms, but rather from well-networked economic agents working collaboratively with knowledge institutions and in an open, creative, and problem-driven way. Innovations are not about building up stocks of knowledge capital created for trade in the knowledge economy. It is rather about continuous processes in a learning economy. Innovations can also take different forms. They can be technological innovations, institutional innovations, or also relational innovations, which are also referred to by the shared creating of shared value by the Shared Value Initiative. This session now ends with 2 questions to you and also your colleagues to reflect on. Firstly, the question is, how in how far does your business share standard operating systems with business partners, or is partnering also in the value chain to improve efficient resource use and productivity in a sustainable manner? Are you doing this already, or are you planning to do this? Secondly, does your company have the necessary measurement and reporting systems in place to assess relevant resource use metrics, including your use of different ecosystem services for which currently market values may not yet exist? And also, are the results of this assessment discussed internally with management or included in your annual financial accounting and reporting system? So these are the questions we would like to close with in this session 5.